In this video, we're going to be going over how to solve what is called an indirect measurement problem. Indirect measurement is basically measuring something without directly putting a tape measure right to it. Now, while we're not going to go outside and do this indirect problem, we're going to use proportions to solve an indirect measurement problem. So I've given you basically a very classic textbook-based problem that a lot of you are going to see in your curriculums that you're studying. So let's check it out. We've got a 3-foot tall child casts a 6-foot shadow. A nearby tree casts a 15-foot shadow. Find the height of the tree. So we're basically going to find the height of the tree without actually measuring the height of the tree. That's why we call it indirect. We're not directly measuring the tree. So what I've drawn for you here with no ability with arts at all is your tree right here, and we don't know what the height of the tree is, so we'll call that X. But what we do know is that it casts a shadow along the ground that is 15 feet. So I'll put a 15 right there. This dotted line represents the light that is hitting the top of the tree and then coming down and basically hitting that tip of the shadow right there. So it's like the sun over here is beaming down on that tree. Very nearby, the sun's going to be hitting a nearby, child's top of the head and causing a shadow to be formed over here. And we're told that that shadow is 6 feet. But we are told that the height of that child, which is terribly drawn, is 3. So the focus here is that we can use triangles, and they are similar triangles, to find the height of the tree. And they're similar, again, because the person, the child, and the tree are both 90 degrees to the ground, and we've got the same angle that the sun is hitting the tree and the child with, forming 2 similar triangles. So later on in a geometry course, you're going to prove why they're similar. For now, I'm telling you, those triangles, those situations, they're similar. So what we do is, like in the previously reviewed word problems in other videos, we want to make sure that we match up the corresponding pieces. So the corresponding parts here are the height of the tree and the height of the child. So that would be comparing X to 3. Then we want to compare the length of the shadow. We're going to start with the length of the shadow of the tree, and that's because we went tree to child, so we're going to stay with that and be consistent. So we'll go tree to child. So 15 is the shadow of the tree, and then the shadow of the child is 6. And now from here, once we've set everything up, we're good to go. So I'm just going to give you this piece of advice. When you go to practice indirect measurement problems like this, practice the setting up first. Practice drawing out the picture and seeing how you can set up your similar triangles, set up your proportion, and then move on to the next word problem that's a lot like it, so that you're getting very good with the setup, because the rest of what I'm about to do is really simple solving of proportions. All right, so let's solve this one out. You've got X over 3 is equal to 15 over 6. So simply what I'm going to do first is simplify the fraction on the right before I cross multiply. So I've got X over 3 is equal to, I'm going to divide the numerator and denominator by 3, the greatest common factor. That gives me 5 over 2, dividing 15 by 3 and 6 by 3. Then all I've got left is to cross multiply. So I'll multiply 2 times X is 2X, and 5 times 3, which is 15. Sweet! So all I've got left, solve that remaining equation. I'm going to divide both sides by 2. And what I have left is X, or the height of the tree, is 15 halves. And as a decimal or a mixed number, it's up to you, I'm going to write it as a decimal. We have 7.5 feet. So the height of the tree is 7.5 feet, which makes sense. And it makes sense because the ratio of the child's shadow to the child is 6 to 3, or 2 to 1. And the ratio, therefore, of the shadow of the tree to the height of the tree must also, therefore, be 2 to 1. And 15 to 7.5 is 2 to 1. There you have it, folks. A video on a classic indirect measurement problem. Hopefully, you're going to feel really good about this problem real quickly. If not, watch the video over again and practice the setting up pieces, as I mentioned earlier.